Ladies and gentlemen, welcome to It's Rainmaking Time. This is Kim Greenhouse. It gives me great pleasure to welcome Dave Stetzer, the founder of Stetzer Electric. He is one of the most experienced people in the area of measuring electricity in the world, anything related with ground current. He has testified before many court cases and in many countries all over the world. Dave's name was brought to my attention because he is a grounding expert, because there are new products on the market that recommend that we ground ourselves in the Earth's energy. And I had tried one of the products that was out there, and it turned out that I couldn't sleep for 3 nights. I got up at 2 o'clock in the morning 3 times, and I thought it would be a good idea to do a segment on grounding, on the Earth's current, on dirty electricity, and have Dave explain to us what this is about so that we're not asleep when it comes to understanding how this all works. Ladies and gentlemen, welcome Dave Stetzer to It's Rainmaking Time. Good afternoon, Dave.
Good afternoon.
Thank you so much for being here. You have a background in the military and electronics, don't you?
That's correct. Yeah, I was in the United States Air Force for 4 years as an electronic technician.
And then you started your own electronics company. How long ago?
Yes, I started my own business in 1975.
And I understand that one of the things that you do is you testify in court cases. You've been involved in research on 30,000 cows.
More than 30,000 cows we've done research on, yes.
Why?
There's something that electric utilities and public service commissions call stray voltage. And voltage doesn't stray. It goes where people put it. So if we name it something like stray voltage, I've always said there's stray dogs and stray cats because you don't know where it's coming from or where it's going. But when it comes to ground current or the stray voltage, we know where it's coming from and we know where it's going. There's laws of physics that govern it. Kirchhoff's law says for every electron that leaves a node, one has to return to a node. The utility substations the generators generate power, electric current, and it goes to a substation. It gets shipped across the country. But for every electron that leaves that substation, which we would be called a node, one has to return for every one that leaves. So what happens is by 1998, there was 2 separate studies done, one by EPRI, Electrical Power Research Institute in Palo Alto, California, and one by the Minnesota Science Advisors, separate studies, that said 70% of all the current that goes out on the phase wires or the hot wires returns via the earth in the United States.
Now, what does that mean?
So 70% of the current that's going out, and when you drive down the road, you see those highline wires, the big wires?
Right.
70% of that current is returning back to the substation via the earth in the United States rather than on a wire. So now we have our cows that stand on the earth, on the ground, and there's these ground currents that enter their body, and it affects milk production, it affects breeding, it affects, they have miscarriages, they absorb, if they do get pregnant, they absorb, it affects their immune system, all kinds of things. And like I said, we've done research on over 30,000 cows.
What does this mean to us walking around? What are the implications?
Well, the implications are that the ground is not at zero potential. People think the ground, think of it like a sponge. And like a sponge, if you drop water on a sponge, it's absorbed, you don't see or feel it or whatever again, right? But if you drop water on a brick, you have to deal with this water. And the earth is not like a sponge. It's more like the brick where we drop water on the brick. We still have the water there. We have to do something with it. So what happens is the current that goes out on the hot wires has to return back to that substation. And in 1992, the Public Utilities Commission said most states allowed the electric utilities to put a ground rod in every pole and use the earth as part of the supply circuits. In other words, there's 2 paths back. One is via the earth and one's on a wire. And 70% of it in 1998 was coming back via the earth. So I would imagine it's a lot more than that today. So where do we stand? On the earth. Where are our cows? On the earth. People will have some of the same effects.
How do we know what's considered dirty electricity? And could you define that for us? What does that mean?
Well, dirty electricity, I would define it as something that deviates from the normal sinusoid. In other words, everybody's seen a 60-cycle sine wave, the up and down waveform. If it's not clean, if it's dirty, or like high-frequency transients, for example. Like a laptop computer, one brand will put 25 kilohertz back on the line. Compact fluorescent lights, for example, will put between 50 kilohertz and 100 kilohertz back on the wires. So now the wire, it's not a clean 60 cycle anymore. It's dirty. It has high frequency writing on it. Towers, 16.5 kilohertz or 12.5 kilohertz will go back on the line just from computers, depending on the brand.
So what has Stetzer Electric done to help us with some of the dirty electricity? I notice you have some products like filters and meters, and what's the context in which those have been created and are being used? Well,
a long time ago, I had some classes in something called radio wave sickness, okay? And radio wave sickness was something that and you can look up the symptoms on the internet, but radio wave sickness is usually, it's caused from exposure to high frequency, okay? And when we were doing research with these cows, the farmers would say, this affects people too. And they would list the symptoms that their family would have. And so if that would be the case, then it would be like they were exposed to high frequency. So the question was, where are they being exposed to high frequency from? And this is back in 1998, so we didn't have wireless internet here in the rural areas. We didn't have a lot of cell phones being used. We didn't have a lot of things like this, no big military installations, close to us or something. So the question was, where are they being exposed to this high frequency from? So I am a measurement expert, and so what we did is we found it on the building's wires, and we found it on the ground. So I can get rid of it on the building's wires by putting a filter there. So I tried it, and these people's symptoms went away. So then we started giving them away, and after that, we couldn't give them away anymore because we had such a demand for it. But for these filters, we put some in a school, for example. 37 kids had asthma. 37 kids no longer used inhalers from the day we plugged them in. And still, that was 6 or 7 years ago now, or 8, I guess more. And they still don't use any kids with inhalers there. So the high frequency does affect people. We know it capacitively couples into the body. So yes, we can clean that up by putting filters in the building and take it off the building's wires.
So any plugs in the walls, we can put in these filters, right?
Yeah. What you would do is Professor Martin Graham made a meter, because I went to Russia and we did some experiments there and I did some research with Russian scientists, and they needed a meter. I use an oscilloscope, so you can actually see the waveform and that. But the Russian scientists said, look, we need our health department to have a meter that you can read this stuff with or see it, but we can't afford $5,000 for an oscilloscope for each person. So anyway, Professor Graham made this meter, an inexpensive meter, that you can plug into the wall. So you need to check every receptacle. You don't need a filter in every receptacle, but you need to check every receptacle. And then you just plug the meter in, you get a number, you plug the filter in. You want to see a significant reduction. If you do, you leave it there, you go to the next outlet and move on. If you don't see a significant reduction, keep moving on. Don't worry about it. The average home takes like 20. The average home has one PC and 2 TVs, so you can kind of adjust it that way.
How about copiers and fax machines and refrigerators?
Copiers, fax machines, TVs. Refrigerators aren't usually a problem because they are what we call a linear load. Refrigerators, washing machines, dryers, although the new wash machines have variable speed frequency drives on now, but the older ones didn't. But they're what we call linear loads, air conditioning units, furnaces, things like that. So they don't really need one. It's just you need to check the receptacles and put a filter in, and you'll be okay.
Now, these filters go from what low frequency to what higher frequency? What is the range?
Well, when I was in Russia, I wanted to find out what the most biologically active frequencies were. So I had to go to Russia, and they told me that it was between 4 kilohertz and 100 kilohertz. Since then, the World Health Organization came out and said it's between 4 kilohertz and 100 kilohertz. The Japanese government said between 4 kilohertz and 100 kilohertz.